Well, welcome back. We're ready to dive into our last topic in Common Core Algebra 2, and that is Intro to Statistics. You're definitely going to need your calculator handy tonight, so pause it and go grab it. So we're going to talk about a lot of terms tonight. Some of them might be new to you, some of them might be old, but either way, we're gonna clear them all up. So population being the first one. When we conduct a survey, the entire set of all the subjects studied is known as the population. However, most of the time, the entire population is not measured, but a sample is taken to infer characteristics. For example, the entire population of our school would be everybody in it, from teachers to custodial staff to the administrators to the sophomore, freshman, juniors, seniors. But if we don't have time to interview everybody, we might just take a sample of them to infer something about Hamburg High School. Maybe we'll just randomly ask 100 of them instead of everyone. So the population would be all, but the sample would be just the 100 that we ask a certain question to. A mean, hopefully you've heard of, and if not, that's okay. But a mean is just our average. And just to remind yourself, the average is what you get when you add up all your terms and divide by the total. And then the big topic we're going to really focus on is the standard deviation. This measures spread or variability. It describes how the scores deviate from the mean. A small standard deviation indicates that the data is close to the mean, while a large standard deviation indicates that the data is spread from the mean. Now, technically, these were all things you covered in Algebra 1. If they sound new, that's okay. We're going to really, slow down and go through them tonight. Here's our first question. 18 students are in Mr. Keel's calculus class. The following are their test scores. So, again, this is all on the calculator. If you have the TI 83 or 84, you are going to be hitting, jot these notes down so you have them, stat, edit. Okay, and under stat and edit, you'll see a list of L1, L2, L3, etc. I'm going to put all of this information in L1. So if you have anything in any of these, here's what you do. You use the arrow up button, you're going to go up to L1, and you are hitting clear only. Do not hit delete. Hit clear and enter to clear anything out. If anything's in L2, clear and enter. L3, clear and enter. If you're missing one of those, that's okay. We can get it back in there for you. However, I'm going to put everything in L1. If you're missing L1, put everything in L2. But nothing should be in these right now. So go up to the top, L1, L2, L3, clear and enter. Once you've done that, we're going to enter all these data numbers into L1 very carefully. Okay, you can see I have mine typed in there. Now, again, jot this down so you have the directions. We're going to go back to stat. We're going to arrow over to calc at the top for calculate. And as far as this class goes, the only button that we're going to use under here for statistics is number 1, and it is called 1 variable stats. We will not be using 2 variable stats, so you don't have to guess, it's 1 variable stats. Now here's where it's going to look a little different on your calculators. Okay, so I've tried to show lots of different things it could look like. If your calculator on the 83 or 84 looked like this, okay, the list is going to be where you typed your information, and same as frequency list. Now, excuse me. If you put your information in L1, that's where your list would be. Did we have any data that we put in L2? The answer is no, we just put information in L1. So if I go down to calculate now, I should get an error message saying there's a mismatch because there is nothing in L2. Okay, so I want to be clear that this is incorrect because I have nothing in L2. So if you got that error, that's why. So you need to go back and you need to say, I only put my information in L1, go down to frequency list and hit clear, and then calculate. If your calculator did not look like one of those setups under 1 variable stats, it's going to look like this. When you hit 1 variable stats, this word 1 variable stats came up, and then here's your big deal. You have to tell the calculator where you're putting your information. So you need to type in L1. For anybody that can't find L1, make a note. It is on the second button, and then you have to hit the number 1 key. So first hit second, and then right on number 1 you'll find L1. But you always have to tell the calculator where to grab the information from. Once you've done that and hit enter, we should get the following data. And here's what we have to understand. So some of this symbol notation may be new to you, and we've got to get it all written out. X bar, and that's how it's read, X with a bar over it. This is your mean. Okay, X bar is your mean. So it might actually be helpful to go up to our notation where we wrote the word mean. Whoops, sorry, that was on the other page. Go up to your mean in your notebook and type and write down X bar. Standard deviation. Probably go back in your notebook and write this symbol down. The standard deviation is this lowercase sigma. You've actually seen uppercase sigma. It looked like that when we did summation notation from 1 to 5. This is lowercase sigma with an X. This represents your standard deviation. Okay. N is the number of terms you typed in. Min, hopefully you can infer min is the smallest number. Q1 stands for quartile 1. Notice there's an arrow here. If you arrow down, there's more information. There's a median. MED would be the median. Jot down your own notes. Q3 was quartile 3, and the max number should be 100. Okay, but these are all things we have to be very familiar with. So the first question we want to jot down, find the mean, median, and the quartiles. So again, when we say mean, we're not going to write out the words, we're going to say X bar. X bar is the mean. We're going to go 3 decimal places in anything that doesn't say. So 83.722. Remember, 3 decimal places. Median, like we said, is fairly obvious. It starts like MED. My median is over here, 84.5. Median is just the number in the middle. And then it says state the quartiles. So quartile 1. When you think of quartiles, you think of what percent? Quarter? 25%. So it's broken up into 25%. Quartile 1 is 75. Quartile 2, also known as the median, we know is 84.5. Quartile 3 is 93. And then obviously the max is 100 and the min is 75. We're going to create a box and whisker for this data. Again, it might be a long time since you've heard those terms, but we're going to talk you through it. So you go from your min to your max. My min was 56, let me remind myself, and my max was 100. So I'm going to pick a number to count by, maybe 5s. So I'm going to start at 55 and I'm going to end at 100. And then I'm going to plot all my data on there. I'm going to plot my min at 56, so just a little, slightly over. My quartile 1 was at 75. Quartile 2, or the median, was at 84.5. Quartile 3 was at 93, and my max was 100. Okay, then what do? You box in the middle 3. Hopefully this sounds familiar. You draw a line down the middle, and you put your whiskers out to the end. It's called a box that goes around the middle 3 and whiskers on the end. And really what should happen in a box and whisker is 25% of the data should be from the min to the first quartile. 25% should be between the first and the second, or the median. 25% between the median and the third, and 25% between the third and the max. Okay, it's breaking it up into quarters, hence the word quartile. Another vocab piece, what is the interquartile range? Well, that is Q3 minus Q1. Quartile 3 minus quartile 1. And that's where these boxes, the end of the boxes are. So I would say that's 93 minus 75, which is 18. What is the population standard deviation? Remember, that's that lowercase sigma. Okay, lowercase sigma, jot it down so you can say it correctly. And that was 11.7. So what does that tell us? On average, any given data point lies 11.7 units from the mean. Okay, now the fun questions. What percent of the scores fall within one standard deviation of the mean? Well, this is simple. You basically write 2 little equations. It says 1 standard deviation within the mean. So you begin with your mean, and your standard deviation can go above it and below it. So you say it's the mean plus 1 standard deviation, and the mean minus 1 standard deviation. Now these are numbers we know. We know the mean is 83.722 plus the 1 standard deviation, which was 11.7. We'll grab our calculator. Let's see, and I got 95.422. And then the mean minus 1 standard deviation, so you take that mean number, and now you subtract 1 standard deviation, because it can be above it and below it, and I got 7.022. Now I didn't actually answer the score yet, we have to count them up. So now you go back and you look at that list of numbers, and you want to know how many fall within this number to this number. So I'll just start. Does 56? No. 68? No. Now does 72 fall in between these two? Well, this is 72.02, and this is less than that. So that bears out, and that bears out. So all of these numbers work. Okay, let's see, does 95 fall in there? I would say yes, but 99 does not. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now if it said how many, I'd be done, but notice it says what percent. So to get a percent, I just divide by the total. I would say that's 11 out of 18. Which is 61.111%. What percent of the scores fall within 2 standard deviations of the mean? Well, it's just as easy. You take the mean and you add the standard deviation twice. And then you take the mean and you subtract the standard deviation twice. So again, I'm going to take that 83.721 and I'm going to subtract 11.7, add 11.7 twice. And then I'll take that 83.721 and I'll subtract it twice. Okay, if it said 3 times, you would do it 3 times. Let's get those values. So I got my range to be from 60.321 to 107.121. So I need numbers bigger than 60.321. So I'd say 58's out, but these guys are all in, and I have to go up to 107, so all of these guys are in. So I would say that's 17 out of 18. All right, so let's try a second problem. A small company has salaries for all of their 50 employees given in this table. All right, so go back to your stat edit, and you're going to clear out anything in L1. Now, the first column is always going to go in L1 if there's columns, and the second column is going to go in L2. So clear that out. And again, I've showed you what your 3 different situations could be. You've got this in L1, L2, or 2 different situations. If your calculator is set up in this mode, you do need to make sure it starts with L1, and now you do put in an L2 because you are using a second list, and then calculate. If your calculator is in this mode, maybe all 83s are. One variable stats, L1, then you need this comma in there. Be careful. It's second number 7, or it's above the 7, I apologize. And then L2, second L2. So hopefully your windows match mine. Now if they didn't, that just means you typed a number in wrong. Go back to stat edit and double check your data. So what is all this saying? Well, the first question says find the mean. Remember that is our X bar symbol, X with a bar over it. So I would say my mean is 42,060. And my standard deviation looks like 16,567.932. B, what is the median, and why is this median considerably lower than the mean? Well, again, the median's given, that's that MED, so our median is 32,000. Now, why is that considerably lower than the mean? Well, the mean was 42,000, and the middle is 32,000. So they're telling me the average is 42,000, but the middle number is 32,000. My gut instinct is to say that this number 120,000 is an outlier. It's so far above the average of these that it's really skewing the data. Part C. Does more or less than 50% of the data fall within 1 standard deviation of the mean? Well, you can't answer that question until you find it. So you take your mean, and notice it says 1 standard deviation. You add the 1 standard deviation, and you subtract it. You're always going to do both. So take your mean, add your standard deviation. Let's see. So when I went 1 standard deviation, again, I added it and subtracted it. Now I have to find the range that falls in there. So if my min is 25,492, 25,000 does not fall in there. I need to be bigger than that, but smaller than 58,627. So I think that eliminates those. So I would say I have 21 plus 14 plus 7, which is a total of 42 out of 50. And that represents, if I divide those two, 84%. So the question was, does more or less than 50% of the data fall within one standard deviation of the mean? So I found one standard deviation, I found how many score that was out of the total, and that represented 84. So yes, it represents more than one standard deviation. So now we're going to throw some more terms at us. Center, shape, and spread. When we talk about shape, the two words we need to be familiar with are symmetric and or skewed. If it's symmetric, the left and right sides are roughly mirror images of each other, kind of like the word symmetry. If it's skewed, it has one noticeably longer tail on one side than the other. A long tail on the right, notice the tail is on the right, is called skewed to the right. A long tail on the left is called skewed to the left. So the whole key is to look where the tail is. The center is just our mean. So here is a histogram. In a histogram, those bars are touching each other. It shows the battery life in hours for 40 batteries. When studying the distribution, it's important to think about the shape, center, and spread. So the first question is, would you describe the distribution of the battery life as symmetric or skewed? Explain your reasoning. I would say that this data is closely symmetric. If I try to kind of go to the center of each of these dots, not all of them, but each of them, I would say it almost looks symmetric. Is the mean of the battery life closer to 95, 105, or 115? Would you say the mean is closer to 95, 105, or 115? Well, again, the mean is going to represent our average. And sometimes you can think of it, if it's symmetric, it should be right in the middle. So I'm going to go with 105, because I would say that's more in the middle of my data. Okay, if I said that was the middle, I should have the same amount on this side and the same amount on this side. So this histogram below shows the greatest drop in feet of 55 major roller coasters across the United States. Would you describe the roller coaster maximum drop as approximately skewed or symmetric? Well, again, if I were to kind of connect the middles here, and again, I'm just kind of aiming for the middle here, does that look very symmetric to you? I would say no. Do you notice how this time you have this noticeably longer tail? Okay, because this tail is on the right, we are definitely going to say this one is skewed. And it is called skewed to the right, wherever that tail is. So is the mean of the maximum drop closer to 90, 135, or 240? Would I say the mean is 90, 135, or 240? Well, remember, mean represents the number in the middle. If you're telling me this is the mean, that means half the numbers are over here and half are over here. I would say no to that one. If you're telling me this is the mean, then you agree half the data is over here and half the data is over here. That's pretty close. If you're telling me this is the mean, you're telling me this side of the data is equal to this side of the data. So I'm going to go with closer to 135. Again, not exactly, but closer to it. So in these last four pictures, I just want to talk about whether we think it's symmetric or skewed. And again, I just kind of, I don't get them all, but I try to go for like the middles of them. I would say that one is more symmetric. There's not a noticeably longer tail. Whereas if I were to connect these guys, do you see the noticeably longer tail? This is definitely skewed to the right. That is where the tail is. This one was symmetric. If I connect these bears, again, I'm going to go with symmetric. There's not a noticeably longer tail. And in histogram 4, again, I hopefully think that's skewed. And again, the tail is on the right, so I'm going to say skewed to the right. Okay, when I'm going to get the means, remember I want half the data to be on each side. So I would say the mean is probably someplace around here, because I would have to have half the data there, half the data there. My mean on this one, again, probably right around there, half the data on this side, half the data on this side. Now it's not going to be smack in the middle on a skewed picture, because remember, you got to have half on each side. So I can't just go to the middle of the picture. There's way more over here than there is here. So I'm thinking maybe someplace around here. I have half the data on this side, half the data on this side. And then same idea here, maybe around this area. And And again, just estimating, it's not exact for now. Half the data on this side, half the data on this side. Well, that covers our intro to stats, and we look forward to a lot of great practice. Stats is heavily relied on the calculator, so make sure that is with you during every video. Have a great night.